Hi, and welcome to the Hominoid Skeleton Comparisons Lab. This is so much like the link between birds and dinosaurs. So the feedback you got in that lab, was it detailed enough? Was it not? Did you do a narrative that showed that you could connect how things were similar and different in their functions physiologically, meaning how the body would operate? That's super important when we're looking at hominoid species. So I need to cut through this one right away. I've had some students refuse to do this lab. That's your choice. But that's also a grade choice you're making as well. And sometimes people do that because they see a conflict maybe with some religious beliefs they may hold, spiritual beliefs. It's okay that you may not believe in evolution, but one of the things I would challenge you to do is look at how this magnificent development of species, how similar but yet different they are, and how just something as simple as the width of the two bones that make up like your forearm could change the way that you live. So let me use that as an example. In this lab, you'll be comparing a variety of different bones. Let's just say these bones right here. Here's a chimpanzee. Here's a modern human, Homo sapiens, and then here is a Neanderthal. And if you start looking at these, you're going to notice a difference. These two are pretty similar. This one is not. Why would that be? Well, you pretty much know how a chimpanzee lives. If you don't, you should research that. Then you're going to be looking at various body parts. You can look at the lab form, and yes, you need to use the assigned lab form. And you'll be running through basically the same rundown that you did when you did the link between birds and dinosaurs. We're just using different species this time, which are hominoids. So all of the diagrams you need are in the lab folder, and some are actually embedded in your lab towards the end. So take a chance to go look at that, and this will give you, this one right here is a really good diagram because it kind of gives you differences in writing so you can look at them. But the differences are all well and good until you can understand how are they functional or not functional to the survival of a human being, or to meaning a modern human versus a Neanderthal and chimpanzee. So Neanderthals are extinct, although many humans have their DNA, including myself. I have 4% DNA of a Neanderthal, or just about 4%. But chimpanzees are not extinct, and Homo sapiens are not extinct. So be thinking about how would each of the comparisons differ, and how does their skull, the orientation of how their spinal column fits in the back of their skull, how do the thickness of their bones, like their legs, their feet bones, their hand bones, how do those marry up to be advantageous for the survival of the species, disadvantageous? Could one be really, for example, these long legs right here that aren't bowed, would that be really good for sprinting or for long haul hiking and long haul, let's say, marathon type approaches? Would the species of hominoids be able to do that, or can they do something completely different? That's what you're looking to do in this lab. As you're journeying through each of these different diagrams, don't get overwhelmed. Just critically analyze how could they help or not help an organism live in their environment. What would that prevent them from doing? For example, when we looked at chimpanzees and they had really, really big forearms, but they didn't have a neck that allowed them to stand upright where the spinal column would be. Why? How does that change how they live? That's what you're looking at doing. This is a really big part of that when we're looking at hominoids, and that is how the skeleton, specifically the spinal column, comes into the base of the cranium, which is the skull. I might even encourage you to look at the morphology or shape of the skull and see how it differs between each species. What does that mean? How could that be an advantage, a disadvantage? How does that relate to potential brain size, also problem solving, and so forth? When you get to the pelvis part of the comparison, now start thinking about how this would translate to several things. Does a wide pelvis or a narrow pelvis help with climbing, with walking, with running, with short burst, maybe attack, combat? What about birthing for females, a pregnant female? Would there be problems with one of these? Could that have led to some kind of problem for one of these species? When you look at the feet and the hands, you're comparing how the morphology, even like of the big toe you see of the chimpanzee, why does it look so different from modern humans and Neanderthals? And what would be the advantage or disadvantage for climbing, for long walking, or short burst running and combat needs? These are the things you're trying to achieve in this lab. So when you look at the difference between these two, you can see that they're not wrong, some of these answers on the left, but compare them to what's on the right. I'm not saying the right's perfect, but I'm saying there's so much more detail that gives me a thorough glimpse into how a student understands the different species bones and how that would be a pro or a con for the environment in which they live. You're striving to do what's on the right. So when you're doing this, just make sure that it's clear to me that you have a strong understanding, an analytical and critical thinking assessment of how these bones work in favor or not in favor for the existence and the environment in which these animals lived. Now, when you get to the questions that you're going to answer, think about how you're answering them. I'm not saying either one of these answers is enough. Matter of fact, I'm going to tell you, while they're on the right track, there's a lot more information that could be provided here. Just like the link between birds and dinosaurs, you need to give me enough information that I can interpret your knowledge base. So I can't read your mind. And your job is to make sure I don't have to when I'm grading this, because if I do, that means you're going to fall short and the grade's going to go down. I want you to have an ace of a grade on this, and you should, simply by thinking about how the organisms differ. I appreciate your time on all of these labs, and thanks so much for watching. Bye.